Hello everyone, let us solve the questions, previous year questions of Ray Optics. First question is assertion reason question. In optical fiber, the refractive index of cladding must be less than that of the core. Now, we know that in optical fiber there is a core and outer covering is known as cladding. And we know that the TIR or total internal reflection would take place only when the ray of light is going from denser to rarer medium. Only then total internal reflection would take place. Otherwise, total internal reflection will not take place. So, in optical fibers, TIR takes place, and obviously here the refractive index of the core is greater than the refractive index of the cladding. So as per this assertion, it is given here refractive index of cladding must be less. So cladding is a rarer medium, so here refractive index is less than that of the core. So here assertion is true. Second is total internal reflection takes place only when the ray passes from denser to rarer medium. So as we know that the work of this optical fiber is to transmit light from one point to the another point with the help of TIR to take place. So why this core is denser? Because refractive index of the core is more than the refractive index of the cladding, so that the ray of light must go from denser to rarer medium. So here assertion and reason, both of them, they are correct, and reason is the correct explanation of the assertion. So here option A would be correct. Question number 2. Why does the water tank appear shallow? Question number 2A part. Why does the water tank appear shallow? Because of refraction of the light. As the light from the bottom of the water tank comes to us and it suffers refraction at the interface, so that is why the bottom of the water tank would appear shallow. Explain. Write the relation between real depth and apparent depth of the tank. Here it is a simple derivation question. Refractive index is real depth over apparent depth. So this is the formula, this relation we can derive. And third part is with the refractive index of water. So this is the refractive index of water. So this formula we can write here, real depth over apparent depth. B part or part is what are optical fibers? Optical fibers are very thin flexible strands of glass or plastic that transmit data. These are thin strands that transmits data as light signal or light pulse from one point to the another point with very high speed and minimum loss. So we have already discussed, this is a theoretical question. So what are the optical fibers? These are very thin strands. So these are made up of glass or plastic, and they can transmit data from one point to the another point in the form of light pulses, and it sends a signal with very high velocity, very high speed. And the long distance data communication can also be the application of optical fibers. And the loss is minimum because light goes from one point to the another point with the help of total internal reflection. And second part of this question is, how does the light ray travel through an optical fiber? So that we have already discussed. It travel with the help of total internal reflection. And give two applications of optical fibers. So two applications of optical fibers can be the telecommunication and second optical application is endoscopy. So these two applications we can write here. Question number 4. This was question number 3. And question number 4 is a glass biconvex lens of focal length, biconvex lens, and focal length is 6.6 meter, refractive index is 1.5, is immersed in a medium of refractive index 2. Find the new power of the lens and nature of the lens. So new power of the lens we have to find out. We can use lens maker's formula. So this is mu over mu of refractive index, this is lens, minus 1 over r1 minus 1 by r. So this is the focal length of the lens in the medium, and focal length of the lens in the air is what? This is lens over refractive index of air, which is 1 over r1 minus 1 over r2. So whenever the lens is immersed in the liquid, we have to use the formula, lens maker's formula, for air as well as for the medium. Then we take the division, because here these term we have to cancel. So you can take the ratio of the two equations here. So focal length in the medium 1 over focal length in the air, we can write this as medium is mu L over mu M minus 1. This term R1 R2 term is going to be cancelled, mu L minus 1. 1 over F dash we have to calculate. Here you would get FA, mu L mu M. Lens is 1.5. This is 2 minus 1, 1.5 minus 1. This would be 1.5 minus 2, 0.5 with the negative sign over 2, and this would be 0.5. So here FA over F dash is 0.5 is cancelled, minus 1 by 2. Or in other words, we can say that F dash is 2 times FA with the negative sign. So F dash is minus 2, FA is 0.6. So this would become minus 1.2. It was in meter. So this has become 1.2 meter. So this is a new focal length, but we need to find out the power. Power would be 1 over F. So this is 1 over 1.2. So simplifying this, we will get 0.83. And here you see this is negative, so power would also be negative. So this is in diopter. So this is a new power of the lens. And what is the nature of this lens? This power is negative. It means it is diverging lens. It would behave as diverging lens. Okay, question number 5. Question number 5. First part of the question is simple derivation question that you all can do. So you have to simply write the relation between U, V and R when the reflection is taking place for the spherical surface, so that we can write mu1 over U plus mu2 over V, mu2 minus mu1 over R. So this relation directly I am writing here. Derivation you can do, but I am concentrating on the numerical part, second part of the question. And from this equation you have to derive the lens maker's formula. So that is already done in the class. Second part is two thin lenses of power plus 20D and minus 5D. So here powers are given as 25 diopter and second power is minus 5 diopter, are kept in contact with each other. Calculate the focal length of the combination. So power of the combination we can find out, 25 minus 5D, using the formula P is equal to P1 plus P2. So this would be 20 diopter. So this is the power, and focal length would be 1 over 20. That would be, here focal length would be in meters. So this would be 0.05 meter. it is 5 centimeter. Now the question is, calculate the focal length of the new combination. So this we have calculated, and an object of 4 centimeter height is placed at a distance of 20 centimeter from this combination. So this is the focal length of the combination. Now the object is placed at 25 centimeters. So this is minus 25 centimeter. What is the position and size of the image formed? So we have to find out V here using the formula 1 over F is equal to 1 over V minus 1 by U. So F here is 5 centimeter. V we have to find out. U here is minus 25 centimeter. So we can simplify. 1 over 5 is equal to 1 over V plus 1 by 25, and 1 over V would be 1 over 5 minus 1 by 25. So this would be 25. Here you would get 5 minus 1. So 1 over V is 4 over 25, or V here would be 25 by 4, and V value is 6.25. So this is the position of the image. So this would give you the position of the image. We need to find out the size of the image also. Size of image, we can use the formula magnification is image size over object size, which is equal to V over U. So I is to be calculated. Object size is given as 4 centimeter in height. V is 6.25 and U was minus 25. So I is what then? 6.25 into 4 over minus 25. So here 6.25 into 4 is 25. So image size would be 1 centimeter. But this negative sign shows that minus sign image, negative sign shows that here image is inverted. And its size is 1 centimeter. So these are the 5 questions of the day. Thank you.